to go on there and then show everybody why you are champions?
I tell you, the pressure is so huge, and we want to manage this innovation part. So when we cross this bridge, we will show them where the real KNUST.
It's certainly one step at a time. Before we let you go, there are lots of challenges around. And last year, you took down one of the biggest challenges. Who do you think is going to be your biggest challenge this year?
And for now, I can't say anything because the innovation challenge has been a problem for all of us. I can feel all schools are complaining. When we go through, then we'll see what we can do. Yeah.
All right, good luck to you guys, and we'll see the champions in action very, very soon. Look, I can't wait for the contest to begin. It's looking crazy already, but we have another coach here with us, Madam from Ho Technical University. Kindly tell us your name. University of Ghana, sorry. Kindly tell us your name and how difficult it was selecting students this year.
Okay, thank you. My name is Na Afiagra. We usually have a standard screening process and we follow the same process. So it wasn't very difficult getting the students because we take them through a standard screening procedure, and that is exactly what we did to get our students.
The reason why I was asking that question is because of the change in the format. The innovation challenge, did it pose difficulties in selecting them? Because now you have to choose students who can actually go and present and convince an audience.
Yes, like I said, we were prepared. We chose students who are prepared for any challenge that will be thrown at them. And from the word go, we informed them that this year the standard is going to change. Things are going to change. So they were ready for whatever was thrown at them. So that is,
that's beautiful. Now, myself, I'm an alumni of University of Ghana, so I'm a bit biased here. Kindly forgive me. But before we let you go, at the start of this competition, it was a monopoly. UMass had been winning. But KNUST has showed us that they can't be beaten. Do you feel like this year will be our year?
It is anybody's game, but our eyes are fixed on the ultimate.
Once our coach says we are going for the ultimate, we are going for the ultimate. Good luck to you guys as well. We'll be seeing University of Ghana in action. It's all set and ready to go. Sit back, relax, and enjoy the live action from the College of Physicians and Surgeons, the GAS Challenge 2024. Innovation Challenge, so there's new things. Sit back, relax, and enjoy. We've got more coming.
Well, right, hello, and a warm good afternoon to you. At this juncture, the University of Ghana and KNUST teams make me feel like it's Christmas already. I'm wondering how we got to Afishapa at this time, but anyways, I am tempted to believe that it's Afishapa for the GAS Challenge team having come thus far, and it being the 5th edition or the 5th anniversary of the GAS Challenge. Ladies and gentlemen, we are here once again for the Day 2 Zone 2 contest. And it promises to be an interesting contest because the contest will be between the University of Ghana, then the Kwame Nkrumah University of Science and Technology, and from Ho Polytechnic. These 3 institutions would have to pitch their solutions together for the judges to make a determination on who qualifies or which of them joins the team of 6 that will make it to the semi-finals. It promises to be interesting. We have seen some interesting perspectives in the morning, and this afternoon as well, we look forward to some exciting propositions and theories. And so, having said that, I think that it will be proper that we acknowledge that our friends from the KNUST are in the auditorium. Our friends from Ho Technical University are also in the auditorium. And our friends from the University of Ghana are also here in the auditorium. University of Ghana, we are grateful. We are grateful for your Jama. Yeah, your friend. Your friend Musa Mumbai, your friend Musa Mumbai, and solutions to the commercial and engineering problems we gave you. And that's why we are here this afternoon. Thank you, University of Ghana. We are grateful. Ladies and gentlemen, The gas challenge this year is another team embracing the future together, driving sustainable solutions in the gas industry through innovation. And this is the innovation edition of the gas challenge. Indeed, University of Ghana says that Omaba and Sudia are ready. We will take their solution this afternoon and find out whether indeed they will be part of the 6 institutions that will make it to the semi-finals of the gas challenge. Having said this one, we would like to acknowledge the presence of our technical committee members. We have Dr. Frank Boatin here and the rest of the team. We acknowledge your presence. We also want to acknowledge the presence of our stakeholders who are with us this afternoon. As well, we also acknowledge our production team, Studio AD, for doing a fantastic job. And also, we would want to acknowledge the presence of our panel of judges. The first on the list is Dr. Emmanuel Ankude, who works or is a lecturer at the KNUST with over 20 years of teaching and research experience. In addition to Dr. Ankude is Engineer Portia, who also works with Petroleum Commission. In addition is our own brother, Sylvester Kujo, who works with the Ghana National Gas Company. Ladies and gentlemen, this afternoon, we are privileged to also be joined by the Managing Director, Madame Genevieve Saki, from the Ghana Cylinder Manufacturing Company. She is the Managing Director. Let's acknowledge her. Madam, we are grateful for joining us this afternoon. Having said this, at this juncture, we want to take some brief remarks. I call it the hello remark from the coaches of the respective institutions. And so at this juncture, we will start from the University of Ghana, who for the first time brings us a new coach in the person of Dr. Na. Let's acknowledge her even as she comes. And she's a female, so she adds to the female pool of coaches that we have. We can do it better for her.
Hello, good afternoon. All protocol duly observed. Dr. Som is the head coach of the University of Ghana team, and then I am assisting. And together with our team, we are grateful to Ghana Gas for the invitation this year to be part of the gas challenge. Thank you for the opportunity to groom our students about the gas industry. And we are very well prepared for this innovation challenge, and our eyes are on the ultimate. Thank you.
Well, University of Ghana says that they are well prepared and their eyes are on the ultimate. We would reach out to whole technical university and find out what their eyes are fixed on. And so we would invite Reverend Dr. Jokoto. Reverend Dr. Jokoto.
Good afternoon. Yes, whole technical university, we are poised to take the final trophy home. Yes. So I do not want to bother you with long talk. It is going to be very exciting, and mind you, who made it up to semi-final last year, and this year we are making it to the final. God bless you all.
Thank you very much, Reverend Jokoto. He says that who made it to the semi-finals last year, and this year they are making it to the finals. We will receive Dr. Daniel Annan from the KNUST. The reigning champions. The reigning champions.
Thank you very much. Lingers! 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 Okay, so we want to thank Ghana Gas for giving us the opportunity to partake in the 5th edition of this gas challenge. As defending champions, we are under huge stress to perform, and we know we will not disappoint you. It is our hope that we'll go through this phase and qualify to the next round of the competition. Thank you very much.
Well, I nearly missed that they are the defending champions. Indeed, they are the defending champions, and so they are here to defend their ultimate prize, whether they can hold it for keeps. But just to remind all of us that right from here, the semi-final comes off at the KNUST on the 5th of November, and then the grand finale will happen on the 14th of November as well here in Accra. So let's all be preparing towards it. Just to state that 6 institutions out of the 12 will make it to the semi-finals. And so I'm sure that everybody will get to know where they placed, how they performed at the end of the contest when everything is summed up and the judges are ready with their results. Ladies and gentlemen, it's been 5 years. From 2019 all through to 2024. The gas challenge fell just at 2020 because of COVID. But we are back bigger and better. Today, the contestants will be solving 2 problems. They will be providing solutions to 2 problems. One commercial and the other engineering based. It is our expectation that these solutions they provide will be able to meet standards in the world of work. Having said that, I would hand over to the judges at this juncture who would remind us of the rules, and after they have reminded us of the rules, then we can invite the contestants up stage. So when the judges are done, I'll come back before they would invite the contestants up stage. Thank you.
Okay. Thank you, Harrison. I believe all the contestants and their coaches have been sitting here from morning. But for sake of clarity, we'll go over some few points on the rules. As he said, there are going to be 2 presentations, one commercial and one on engineering. So each of these, you'll be given 15 minutes for your presentation. Then after that, the judges will take turn to ask questions. Now, the highlight of the other thing on this is that after about 10 minutes, you'll be reminded that you have 5 minutes more. Now, after all the contestants have presented, mind you, we started from yesterday. So at the end of this round, that means 12 schools would have presented. The top 6 schools qualify for the next stage. So we'll be adding up all the presentation marks, and then you can easily determine where you find yourself. Then those 6 schools go on to the next stage. Then by coming here and agreeing to what Ghana Gas is organizing, take note that Ghana Gas retains exclusive ownership rights to all materials, documents, presentations, and intellectual property developed, submitted, or created during the competition period. So you have acknowledged that all intellectual property rights, including copyrights, trademarks, and patents, are now vested in Ghana Gas. So by participating, contestants grant Ghana Gas unrestricted, royalty-free, and irrevocable rights to use, reproduce, modify, and distribute such materials. Any questions? Okay, Harrison can take it over now.
So, like I said, it's been 5 years, and it would be interesting for those of us watching for the first time, those of us online, and those of us here in this auditorium, to know what the journey has been so far. And so this is how the journey looks like the last 5 years.
In May 2019, the Government Relations Department of the Ghana Gas Company birthed an initiative that would ignite minds and fuel competitions. This is the Gas Challenge, a pioneering production designed to deepen the engagement and knowledge of Ghana's energy sector. The very first. In May 2019, the Government Relations Department of the Ghana Gas Company birthed an initiative that would ignite minds and fuel competitions. This is the Gas Challenge, a pioneering production designed to deepen the engagement and knowledge of Ghana's energy sector. The very first edition, dubbed the Stakeholder Edition, brought together key players in the gas industry. Institutions like the Ministry of Energy, the Energy Commission, the National Petroleum Commission, and even the Daily Graphic took part in a friendly but fierce competition. It was a battle of wits and knowledge, where the Ministry of Energy ultimately emerged victorious. In 2019, the challenge evolved. The student edition was launched, pitting some of Ghana's top universities against each other. Universities offering courses related to the gas industry, such as the University of Ghana, Kwame Nkrumah University of Science and Technology, University of Mines and Technology, and others, faced off in an intellectually charged atmosphere. This was no ordinary competition. It was a battle for supremacy in the energy sector. The competition, held across 3 major regions, Greater Accra, Kumasi, and the Western region, saw the University of Mines and Technology, UMAT, clinch the title in the very first student edition. For 3 consecutive years, UMAT would continue their reign, proving their dominance in the field of energy education. But the Gas Challenge didn't stop there. It grew. New institutions like Ho Technical University, Kumasi Technical University, and Tamale Technical University joined, bringing the total number of competing universities to 12. The competition became tougher, the stakes higher. And then, after years of dominance, the unthinkable happened. In a dramatic turn, KNUST dethroned UMAT, marking a new era in the Gas Challenge's storied history. The challenge paused only once, during the global pandemic of 2020, but it returned stronger, more resilient. Now, as we celebrate the 5th anniversary of the Gas Challenge, we reflect on the lives this competition has impacted. Many former contestants are now thriving in key roles within the energy sector, both in Ghana and beyond. The challenge has not only sparked intellectual growth, but has opened doors to endless possibilities. 5 years of excellence, innovation and competition. The Gas Challenge, where knowledge is power and gas is the future. Knowledge is power. Gas is indeed power.
We would have the first presentation on the commercial issue, and that will be done by the first team, University of Ghana.
Okay, welcome University of Ghana. They go by the name Propane. We have a lady and a gentleman on stage. Please introduce yourselves.
I am Joseph Opoko Friye, level 300 chemistry student.
I am Winifred Akufo-Foria, level 300 student, University of Ghana.
Okay, thank you. Yeah, as we said, you have 15 minutes to tell us about the commercial solution to the problem given to you. So if you are ready, and timekeeper, you can start now.
Thank you very much. We are here presenting on the commercial phase of our innovation project. We were given 2 products and 1 consumable, which is a glycol, and the 2 products was LPG and pentane. But for this whole presentation, we are going to focus on utilizing pentane to reduce the flaring of CO2, to reduce the flaring of pentane in the gas sector. This presentation is going to highlight key points like the utilization options of pentane, the demand centers, the nature of the demand centers right now, some pricing recommendations in the sales, and how to mitigate risks associated with our utilizations. Since the discovery of gas and oil in commercial quantities in 2007, the oil and gas industry has seen significant expansion, but not all their resources have been utilized just yet. As part of this expansion, the GNGC has instituted the Pentane Recovery and Monetization Project to efficiently manage their hydrocarbon resources. However, gas processing companies face challenges in managing heavy hydrocarbons, specifically pentane. This could be due to the challenges in storage or the challenges in transportation. Currently, about 2,400 meter cube of isopentane is being flared monthly, leading to more CO2 emissions. Therefore, we are here to propose a means by which we can monetize pentane. The objectives of this study, by the time we are done with this presentation, we will give various utilization options, assess the demand and supply, recommend some pricing for the sales of pentane within this utilization, give a revenue projection and environmental impact assessment of our utilization. Now, when it comes to pentane, there's a lot of uses. In specialized ICE engines, in specialized ICEs, it could be used to power vehicles and used for power generations. It can be used as a blowing agent in the production of some polymers like polystyrene, from which we get our styrofoam. Isopentane can serve as a natural refrigerant to replace the traditional CFCs that destroy our ozone layer because it has a low global warming potential. However, for this presentation, we are going to focus on isopentane's use as a working fluid in ORC systems to generate power. We are going this way because we want to, as part of utilizing our pentane, we also want to utilize waste heat in industries and also help in the transition to cleaner forms of energy. We have here in this slide two processes. Process A, that has to do with the stabilization of pentane right from its processing hub, and B would be the organic Rankine cycle. From the production of pentane in the gas processing hub, it first goes through an air cooler and then further to a chiller, as you can see here, and then to a tank where it is stored under specific pressures and temperatures. Then it is pumped to dedicated bulk road vehicles to be delivered to the utilization sites, at which will have ORC systems incorporated to their waste heat vents. So in the ORC system, the fluid, which is our pentane, is pumped with the evaporator where it is heated, vaporized, and this heat and vapor turns the turbines in the expander connected to a generator to generate electricity. This fluid is condensed, and then the cycle goes on and on again. To reduce the workload on the evaporator and condenser, you can have a modified version of this ORC, which will be to incorporate an internal heat exchanger, which will preheat your fluid going to the evaporator and pre-cool the fluid moving to the condenser to reduce the workload on these two parts of the ORC systems. As part of one important part of this ORC system is this heating source. So as part of our demand centers, we want to pitch this idea to companies that produce waste heat, like mining companies like Goldfield, Persis Mining, Adamus Resources, and power generation plants like thermal plants, and other industries that use waste heat, like cement producing companies. The nature of the demand centers is that currently isopentane is not being used, but with the incorporation of ORC systems into the processes of these industries, they say this brings a vast potential for the utilization of isopentane. Establishment of medium-scale or large-scale ORC plants would significantly increase the demand of pentane. At this point, I would hand over to my teammate to take over.
Okay. Assessing our demand and supply assessment, we expect that isopentane would be supplied in needable quantities by these demand centers as determined over here. The total amount of isopentane from our supply data is about 2,400 meter cube, approximately, which is equivalent to 1,502.4 metric tons. Assessing our demand centers, we realized that the mining companies would need more of the isopentane produced, which is equivalent to 69%, with a total ORC installed capacity of 17.5. Thermal plants would have would need an average of 23%, with an equivalent ORC capacity of 5.82, as well as IPPs will need a percentage of about 8%, equivalent to an ORC capacity of 2.0. The total amount of energy that can be produced from the supplied isopentane is 25,320 kilowatts per hour. Our recommended pricing method will be the netback pricing method, which calculates the net revenue that a producer retains after deducting all costs associated with bringing the product to the market. Some advantages include transparency, cost control, as the cost would determine the impact of the cost will be assessed on the net revenue, and market adaptability, helping producers to adjust their pricing strategies according to market conditions. Some disadvantages include complexity in the calculation of the netback pricing and market sensitivity, as fluctuations in market prices would affect the profits made. In our netback analysis, we're going to use some parameters such as the sales price, the royalties, production, transportation cost. We assume the market price of isopentane to be $500 per metric ton, the royalty $25 per metric ton, and a production cost of $125 per metric ton. Our transportation cost was $15 per metric ton. Our netback pricing was projected to be $335 per metric ton. Using this method, the gas company will retain a $335 per metric ton after deducting all costs associated with the production of isopentane, using a market price of $500 per metric ton. Some risks associated with the use of isopentane in ORC systems include flammability due to the volatile nature of isopentane, and then exposure to isopentane leads to health issues such as respiratory irritations. Isopentane is a volatile organic compound which can lead to air pollution. Failures in ORC systems can also lead to downtime operations in the industry. Some mitigation measures put in place include ensuring safety protocols, adhering to regulatory compliance, making sure that there's a reliable supply chain management, training and awareness of employees, emergency preparedness in time of need, and environmental controls to prevent emission of volatile organic compounds. In our revenue projection, the monthly cost was projected to be about $225,000, with a half-year projection of about $1 million. The profit was calculated by subtracting the monthly cost from the monthly revenue. The monthly revenue was calculated by multiplying the monthly production by our average selling price, which we projected to be $335 per metric ton. Our monthly profit was projected to be about $278,000, with a half-year profit of about $1.7 million. This table here shows a summary of our revenue production. In regards to evaluation of utilization options, it includes value addition for pentane, which would have otherwise been flared. Our revenue calculated also shows that the revenue is going to be stable, and then we can predict the revenue streams of these utilization options. And also, it reduces greenhouse gas emissions. Some positive environmental impacts include reduction in flaring.
You have 5 minutes more, please.
Leading to a decrease in CO2 emissions and energy efficiency, harnessing of waste energy. Some negative impacts include risks associated with flammability due to the volatility nature of isopentane, resource extractions associated with the extraction of natural gas and its processes and transportation, and also air pollution. Our proposed governance structure is going to be the hierarchical organizational structure headed by a board of directors, an executive management team consisting of the CEO, a chief financial officer, a chief technical officer, and a chief operating officer, and a safety compliance committee, market analysis, and a business development team, and a sustainability officer. One advantage of this governance structure is that team management is accountable to their superiors. A disadvantage is that there is a delay in decision making. In conclusion, we are going to be using isopentane as a working fluid in our ORC plants, coupled to thermal plants and mining companies to make use of our waste heat. Our utilization option would help to monetize the product. Our pricing method chosen would be the net-back pricing method, and our company is going to adopt the hierarchical organizational structure in its operations. This is our reference list. Thank you.
Thank you. Thank you, thank you. Thank you.
Thank you very much, University of Ghana. Now we will take the presentation on a commercial issue from the Kwame Nkrumah University of Science and Technology. The reigning champions, Team Lingas.
KNUST, you are welcome.
Thank you.
Two gentlemen, can you introduce yourselves, please?
My name is Robert Osu Ifiakwa, and I am Okanyansa Julius.
Please tell us the courses you are offering and the year.
Okay, so I'm a final year biomedical engineering student. I'm also a final year petrochemical engineering student.
So you know the rules, it's for 15 minutes. So tell us all about your solution to the commercial problem.
Okay. Thank you very much. We are here today to present on the alternate utilization options of product from the Ghana National Gas Limited Company. Here's our outline for our presentation. We're going to start from the introduction. We talk about the utilization options we identified, as well as the demand centers we considered. We also talk about the pricing strategies and the revenue projections and risk mitigation and environmental impact. Finally, conclude on the project and give recommendations. Here's the introduction. So, Ghana Gas processes raw gas from producing fuels to produce commodities such as LPG and pentane. And in gas processing, glycol, which is monoethylene glycol, is used to dehydrate gas, and it is regenerated and finally disposed after it has lost its quality. In Ghana currently, LPG is generally used as a cooking fuel, and at a lesser extent, it's used in the automotive application. Pentane currently is not commercialized, and for glycol, it is not utilized since it is being disposed. So there is a need for us to identify alternative utilization options for these products mentioned here, and we're going to talk about them in the next slides. So here's the objective for our project. We're going to investigate the utilization options for LPG, pentane, and glycol, analyze the demand centers, propose suitable pricing mechanisms, and project revenue and assess environmental impact. This table gives a summary of our utilization options and the demand centers we identified. We identified 3 utilization options for LPG. We have small-scale power generation, petrochemical feedstock production, and industrial heating. For pentane, we identified it as a viable utilization as a blowing agent for polyurethane foam production. And for the waste glycol, which is the monoethylene glycol, we identified as a co-solvent in water-based paint industries. Now, for our demand centers, small-scale power generation here, we are considering the adoption of LPG-driven generators to replace the traditional diesel fuel generators. And this will be utilized by hospitals, educational institutions, small and medium-scale enterprises, and also hotels. In this scenario, there will be a cost of importing LPG-driven generators into the country, and also a cost of retrofitting the current diesel fuel generators to use LPG, since LPG is a clean fuel and in a response to the global call for low carbon investment on the continent. For petrochemical feedstock production, we considered cracking the LPG using a steam cracking plant to produce essential commodities such as ethylene and propylene, which will be used by the plastic manufacturing industries to produce plastics. And since there is a high demand for plastics, this will be a high demand utilization scenario to consider. LPG as a fuel for industrial heating. So we considered the use of LPG as a fuel for industrial heating to replace the traditional heavy fuel oil used in burners and furnaces in the various industries for industrial heating. But currently, lean gas is used by the ceramic industries in the western region for the production of tiles. But in areas where construction of pipeline, as in the case of clean gas, which requires the construction of pipeline, is not feasible, or in remote areas, then there will be a requirement for LPG to be utilized in this sense, where LPG is the clean fuel. Considering pentane as use as a blowing agent in the polyurethane foam production, we considered ash foam Ghana and latest foam as our demand centers. But in this utilization, pentane is considered to be a blowing agent to cause expansion in the foam production, as well as create the cell structure of the mattresses we use. So, moving on to the waste glycol, the monoethylene glycol, we considered it to be a co-solvent in the paint industry, specifically the water-based paint. So it is going to facilitate the film formation and also reduce the dehydration rate of paint, therefore preventing cracking during drying. So this table also summarizes the pricing strategies we adopted for the different utilization we identified. For power generation, we identified penetration pricing to be the appropriate pricing strategy for us to use. So in this scenario, penetration pricing is a pricing mechanism in which businesses attract customers by offering a low initial cost of the product. So since there will be adoption of LPG-driven generators and also considering the cost of retrofitting the current diesel fuels generators, there will be a need to reduce our LPG price at the initial phase in order to get customers or get a market share for this. So it's just like an incentive for us to draw customers to this utilization scenario. For petrochemical feedstock, we are going to use market-based pricing. This is because petrochemical feedstock industries, they are export-oriented industries and highly rely on global market prices for its operation. So there is a need for us to, based on the current price of the current price for the petrochemical feedstocks, which are being imported by our local petrochemical industries, so that we can price it to avoid competition with the global market. Then, considering the industrial heating and the glycol as a solvent, we use cost plus pricing. In this pricing mechanism, what you do is you add an allowable rate of return to the cost of production or to the cost of producing this product. And for the pentane for foam production, we consider the net back pricing as our pricing mechanism.
Okay, so there is a need to address the revenue projection for the stated different options that were earlier stated for the products. That's one, pentane, LPG, and the other was MEG, that's monoethylene glycol. Data was actually given on LPG. So we focused on our revenue projection on specifically the use of polyethylene and polypropylene for the revenue projection for this above presentation. So we used the yield percentages in order to estimate the amount of polyethylene and polypropylene. That we used its percentages to know the amounts for ethylene and propylene from the actually given amount of LPG in the above presentation. So we can see that the blue line up here helps us know that the revenue projected was above 50 to 70,000, 500 to 700,000 US dollars, and that was for polyethylene. And from 300,000 to 500,000 was that for polypropylene. And this was due to the fact that for ethylene, the yield percentages are quite higher than that of propylene. So with the introduction of new utilization options, we'll definitely call for risk that needs to be implemented, and risk that needs to be addressed and mitigation measures should be used to reduce this risk. So for power generation, looking at this first utilization option for LPG, we converting diesel fuel generators to LPG fuel generators would tend to bring about risk in the costing of this conversion, and also affects the economics and finances of this utilization option. And with further future indices, we will be seeing that LNG as another fuel can also be used in this specified option. And LNG will definitely cause competition to be faced with the LPG that is currently being recommended. And the utilization option for LPG in the petrochemical feedstock sector. Well, with this, the nature of petrochemicals tends to be export-oriented. So it tends to affect the market during times of price volatility, which tends to affect the economics and finances of this particular option. And the utilization of LPG as fuel in industrial heating tends to affect the safety of human life and also the environment due to its property having a very low boiling point. So LPG is known to be volatile and also flammable. And also looking at waste glycol, that's glycol as solvent. Glycol is also a toxic compound. So definitely it also causes and compromises the safety of the human health and also the environment. So we address mitigation measures to account for these earlier stated risks. Standard operating procedures were implemented. For example, the implementation of mitigation measures that we're looking at maintenance programs that will help reduce the leaked LPG into the atmosphere. So we tend to ensure that SOPs such as these maintenance programs will help handle the LPG during its production and transportation. And appropriate pricing methodologies were also ensured in order to ensure the adoption of these options for the products and also reduce its fluctuations and also increase its competitiveness within the market. We also looking at the global call for low carbon development projections. We tend to convert the diesels and also the HFOs to the use of LPG, which would help reduce the amount of emissions produced. And also looking at the last stated mitigation measure, that's the implementation of long-term contracts will help us reduce the disruptions within the supply and market demand and also ensure projects and guarantee access for the buyer and also for the seller would ensure financial guarantee. So I'll be leaving this side to my colleague.
Okay, so with this, so now let's consider the environmental impact for the different.
You have 5 minutes, please.
So environmental impact of the different utilization options we identified. For small-scale power generation, we could see there will be emissions, all right, because LPG is still a fossil fuel and doesn't give an absolute effect when it comes to global warming. So we still expect some emission, but at lower level. For the negative effect, that is the negative effect. For the positivity, it's expected that LPG being a cleaner fuel is going to reduce these emissions. Now, for petrochemical feedstock production, we are going to focus on closed-loop system for recycling byproducts. Establishing such a plant, we can have the opportunity to feed back a pentane, which is a potential greenhouse gas, back into a system for either adding up in chemical reaction or be used for power generation. So, and we also have the negative side for petrochemical feedstock to be the generation of emissions such as CO2 and other pollutants. Now, for industrial heating, since you are using LPG, it still holds and it's still similar to the previous. So there is reduction in emissions, all right, and also particulate matter in particular, which also help reduce maintenance costs and others. And finally, it contributes to low global emissions. Now, optimality. Having talked about these utilization options, now, which of them will be optimal for us to implement in Ghana? So, for petrochemical feedstock production, there will be high cost of capital investment at the initial phases, and also currently there is high global fluctuations. There is high fluctuations in the global prices. And looking at the economy of Ghana, you face challenges in implementation. But for it produces a higher economic value and also reduce imports because currently the local industries are importing. So weighing this, petrochemical feedstock will be a viable option in the longer term where Ghana's gas reserve has expanded and has reached a different level. And also the production rate for LPG is not enough to suffice the basic use as cooking fuel and for this as well. So it's a longer term viable option. But for power generation and industrial heating, they still remain as viable utilization option in the present. Now for pentane for polyurethane production, we are going to consider it currently because we have a high demand for it. Now, considering the free education policy, there is high number of people going to school and purchasing mattresses. So for the foam, we're going to still consider utilizing painting for this option. Now for waste glycol, we have a smaller market. This because for the paint industry we considered, even within, we use a very small percentage of glycol in operation, and the cost of purification will still not be viable. So in conclusion, having talked about the utilization options and their demand centers and analyzing the revenue projection, LPG used for petrochemical industry and LPG used as industrial heating purposes and power generations were viable options we chose. Now for the recommendation, so it will be recommended that for immediate utilization option adoption, you're going to consider industrial heating and power generation in the short term, but as Ghana economy grows and also there is expansion of our natural gas reserves where we get a very high LPG production without any importation of LPG, then we can consider the petrochemical sector as a viable option. Then pentane also remains a viable utilization option as a blowing agent to be used in the foam production. So here's our reference for our project. Thank you.
Thank you. You can leave the stage now. We'll call you back.
Thank you very much, KNUST. And now we have Who Technical University.
Okay.
Welcome the gentleman from Ho Technical University.
Thank you.
Can you please introduce yourselves?
My name is Anigbaku Augustine, offering automobile engineering, and I am in level 200.
I go by the name Nyave Mauli from Ho Technical University, level 300, electrical engineering.
All right. Okay, Team Alkane, if you are ready, 15 minutes, tell us about the commercial solution to the problem.
Okay. We are here today to talk about the commercialization of some products, which is LPG and pentane and glycol being used as the dehydration of these products. Our presentation outline includes the following: product overview, commercial utilization option and likely demand centers, nature of the demand centers and demand and supply balance, true to environmental impact of the proposed utilization options, and our ideal governance structure. Our aim is to commercialize these products to maximize their impact in the market and also see their economic growth and as well as their sustainability in the market. Looking at our product overview, LPG is an environmental friendly fuel primarily used for cooking, and it contains propane and butane. In the other hand, propane is a pentane is a highly flammable hydrocarbon in the alkane family that can be used to generate electricity by the use of what? General or some special generators. Talking of the glycol used in the process of dehydration, the glycol produced in the composition given to us by the company shows clearly that if the company uses the glycol, which is the clean glycol, it is being disposed of after it has been used and the color changed to what? Pale yellow. Our proposal is that the company can regenerate that fuel yellow glycol by the use of the regeneration process or the unit in order to gain money or to prevent buying new glycol for another product, another dehydration process. So per the composition, it was given that glycol is being disposed, and that glycol that is being disposed by the company every month is about 150 liters. So this 150 liters of glycol being disposed can actually be regenerated by the company in order to gain some money. And this money that they can gain within the period of 6 months will be about 1,350 US dollars, which will help the growth of the company. LPG utilization options. LPG is basically used for the cooking purposes in our homes and also can be used as the alternative fuel in certain automobile or vehicles. It can also be used in agricultural settings, such as the industry for drying purposes. Looking at the utilization options of the pentane, it can be used to generate electricity by the use of specialized generators and also can be blended with another product to boost the octane rating of gasoline. Also, it can be preferred for cleaning and degreasing purposes. This is because of its low boiling point and its good ability to be a solvent. Also, it can be used in the refrigeration sector as what? A refrigerant. And for that matter, a natural refrigerant. And can also be used as a blowing agent in some industries. And can also be used in different aspects as well. These are some key factors influencing the demand of this product. We are talking about the pentane and the LPG. Economic growth can contribute to the demand of these products, and also urbanization, which is the movement of people from the rural areas to the urban areas. And in these places, they don't have the bio fuels. Therefore, they look for the LPG utilization rather. Government policies such as the LPG recirculation model also helps in the demand of what? LPG in our time. And also the technological advancements, like recently the Atuabo plant, they are trying to build a second phase of it, which will supply pentane to Jomoro fertilizer plant that will be constructed. And this will be done by any company in partnership with the Ghana Gas.
Continue.
Environmental concerns also can lead to the demand of these products, such that we are looking at the use of clean fuel options. So the LPG and then the pentane can help reduce the use of biomass or the charcoal and the firewood in our time. For the LPG demand and supply balance, I would like to leave it to my colleague to continue.
The LPG demand supply balance simply relates the equilibrium between the demand and supply of these products. And the equilibrium between these products also affects the market of these products. And this includes the demand growth. The subsidies on these fuels and the clean fuel initiatives drives increased demand. And how do we curb this demand? The government initiatives such as the cylinder recirculation models also aim to increase the access of LPG. Supply strategies such as the CRM will speed up the LPG distribution, and target marketing will also contribute to a rise in the supply of this product. LPG production is also under demand-supply balance. The domestic production of this LPG is insufficient currently, and demand is in excess. Therefore, the West African Gas Pipeline guaranteed a consistent supply of this natural gas for LPG production. Some of the challenges this demand and supply balance faces are the limited storage due to limited infrastructure, and also economic factors such as the lack of subsidies and fluctuations in the global oil prices. Pentane market dynamics simply talks about the relationship between the market and the product, and this is influenced by demand. Pentane is used as a solvent in pharmaceuticals as well as blowing agents in the production of expanded polystyrene. The emerging demand of this product is its use in pharmaceuticals as well as refrigeration and the power generation, uses specialized generators such as the organic Rankine cycle system. Investments in infrastructure like the gas processing plant or power generation system will also help curb these market dynamics. Some of the challenges the pentane demand supply faces is the import dependency. Data indicates that there are 12 active pentane importers in the country with major players like Lita Pharmaceuticals Limited and the Ernest Chemists Limited. Despite the potential of pentane, infrastructure is limited, and which is necessary for the widespread adoption of this product. The product pricing methodologies that we adopted for LPG and pentane is as follows. The LPG is benchmarked against the Argus international price, which means that the fluctuations in the butane price in the international market affect the price of LPG in Ghana. And the pentane, on the other hand, is benchmarked against the energy content of the fuels. And the netback pricing mechanism is used.
You have 5 minutes more, please.
And the netback pricing mechanism, it is used specifically in the oil and gas industry to determine the price of products by calculating the revenue received after deducting the cost of processing, after deducting the cost of sending these products to the market. Some risks associated in the utilization of these products includes the following. For LPG, the price volatility is a risk which is influenced by the butane price in the international market, as it directly affects the pricing of LPG in Ghana. Competition from alternative fuels. As we are moving towards the decarbonization, along the way, this product is going to be downgraded. Safety hazards, as in this product is highly volatile and burns, and this can contribute to what? Hazards. Environmental impact. The leakage of this product into the atmosphere can also what? Pollute the environment. Health hazards are also some of the risks associated to the use of the LPG. Pentane risks, on the other hand, is associated with the limited demand, infrastructure constraints, potential environmental hazards, competition from alternative blowing agents such as bicarbonates, carbon dioxide, and nitrogen gas. Also, this product also poses health risks as long exposure to this product causes irritation. Some risk mitigating measures include enhanced safety and monitoring, as LPG can be authorized using mercaptans to detect leaks and attend to the leaks, conforming to strict safety standards to minimize risks of accidents, and also regular inspection and maintenance to help address potential issues. Equipping workers with knowledge about the safety handling practices and the likelihood of the accidents and exposure can be significantly reduced. Educating on the potential dangers is also another risk mitigation measure that can promote responsible behavior and create a culture of safety. For the revenue projection, we were given the total LPG produced to be 51,322.8 metric tons, and we assume a product pricing of $550 per MT. And the revenue accrued during the given period is the total LPG supply times the price of metric ton, and this amounts to $28,227,540 For the pentane revenue projection, the value of pentane produced per month is 2,400 cubic meter, and we assumed a pricing of $500 per cubic meter based on its energy content. We also have some associated costs such as the transportation, processing, and other costs, which amounted to $100. The total pentane production for the given period amounts to 14,400 cubic meters. And taking the netback price into consideration, it is when we deduct the cost from the revenue price, and this gives us a netback price of $400 per cubic meter. And the revenue projected for pentane amounts to $5,760,000. The optimal utilization options for this product for LPG, the optimal utilization method is used as cooking fuels, considering other use of LPG. Pentane, the optimal utilization choice is for power generation. Some of the environmental impacts of this product includes, for LPG, we have reduced deforestation as it curbs the deforestation of plants for the use of charcoal and associated fuels. It also reduces air pollution and lowers greenhouse gas emission. Pentane, on the other hand, reduces the carbon footprint as compared to traditional fuels like diesel, as diesel release more carbon footprint compared to pentane. For the negative impacts, the LPG is volatile and can contribute to global warming, and pentane is a volatile organic compound and contributes to the formation of ozone and smog. Mitigation measures for this environmental includes the promotion of efficient combustion, preventing leaks and spills, and also the proper disposal of waste. The governance structure is essential for the implementation of all these projects, and the head of it all is the board of directors, which takes care of the government. And down we have the executive management, which includes the chief executive officer, the chief operating officer, as well as the chief finance officer, who are responsible for the implementation of strategies. And down we have the advisory committee, which is not directly under the governance structure, but provides expert advice on technical and operational strategies. In conclusion, the commercialization of LPG and pentane will present significant options in various industries, such as...
Okay.
Thank you very much, O Technical University. We will do some housekeeping issues whilst the contestants prepare to receive their questions from the judges. And so please be on stage. Just to remind you that the ambulance team is right here in the auditorium, and so at this juncture, if you feel sick, maybe because you can see the team, they would assist you. Housekeeping issues, the washrooms too are just beneath this auditorium, and so if anyone needs to use the washrooms, please go down there and then you can find the washrooms. Thank you.
Okay, as you take your seat, thank you for such good presentations. This is what you have been waiting for, the questions, the opportunity to tell us what you know, isn't it? The presentation is something you prepared. Now let's see how you explain what you prepared to tell the audience. So as usual, we start from the lady.
All right, thank you very much, Doc. And kudos to the teams. I think that was a great presentation you put up there. So we want to test your understanding of what you presented and be sure indeed you really know what you were about. Starting with University of Ghana. I would want to find out why you chose to focus all your discussions on pentane and not think of, the commercial utilization of LPG in your discussions. And also, I want to know if you know of any possible utilization of glycol. Yeah.
Because LPG is currently in demand.
We wanted to make our utilization, the solution we would suggest to be in favor of the energy transition, to be in favor of the reduction of the CO2 emissions, which flaring of pentane plays a major part in. So we were thinking that if we could just get all of those pentane that is adding up to the CO2 emissions and make good use of them, then we can help in that energy transition, along with some SDGs, SDG 7, SDG 13 as well. That is why we decided to focus on pentane, because it's being flared.
Okay, looking into LPG would have also served as a better usage of the fuel in terms of reducing carbon emissions.
LPG in our part of the world has uses which is similar to where what is being used mostly outside, and it has quite some applications and is being used quite well here. But the pentane is underutilized, it's undermonetized. So we wanted to focus on that one instead of the regularly used one.
Yeah. And on the use of the glycol can be used as a solvent in the extraction of paints.
Great. So I hear you when you say that LPG, as of today, has a market or is being used. But really, the expectation from us was that what will be the alternative uses? And you notice that one of the key components of your requirement was for you to talk us through the optimum or the optimization. So for instance, yes, LPG is being used predominantly within the residential subsector. However, the expectation is that you will do your analysis and then make a case why it should be, a different market should be looked at. So you were expecting that in your report and in your presentation as well. So maybe you need to take notes and then we can have a discussion around that. KNUST. I'll come back. KNUST, explain to energy transition advocates. So one of your colleagues, or there's an international or national energy transition advocate, explain to that person why LPG is clean fuel.
Okay, so looking at the currently used fuels, that's diesel and also HFOs that are being used in there. So for diesel in the generators and HFOs as fuel for industrial heating, we comparing that to LPG. LPG has a lower global warming potential as compared to these fuels. So with we using LPG as alternatives of this fuel would definitely help reduce the emissions of.
So I would like to chip in also, whenever there is consideration for emissions, and it's normally from the amount of carbon dioxide produced from combustion. So LPG, which comprises propane and butane, the amount of CO2 emitted after combustion is lower as compared to the higher levels fuels. Thank you.
All right, thank you very much. KNUST, in your submission or in your presentation, you spoke about risk associated with LPG, right, and then glycol. Could you, I think you left out pentane, could you kindly let us know the possible risk that can be associated with the usage of pentane? Thank you.
Pentane is actually volatile. So just use it for me. All right, so Looking at painting, more work was done on it. So we're looking at painting as a blowing agent in the foam production. Painting, it's volatile. So when not handled properly, it can evaporate during its production and also the transportation of painting to these foam production markets.
We can also consider painting to have a minimal risk in that for the utilization we considered, there was no chemical reaction. So we were to use the exothermic heat produced to just vaporize the painting to fill up the molecular spaces to enhance the material structure. So with this taken into consideration, there is minimal risk for painting utilization for what we did.
So you don't think it has any safety issues or safety-related concerns when handling it?
No.
You don't think so? Zero?
Not zero, but no.
Not zero, but no.
Yeah, particularly to the utilization we considered in that sense.
All right, thank you. Then my third question? I don't remember. I think you missed out on your governance structure in your presentation. It was something you were supposed to look at. So could you run us through what your ideal governance structure would have looked like if you had to present that to us?
Okay, thank you very much. So actually, we covered that in the report, and we couldn't add it to our slides. Yes, that's true. So we have board of directors. So for our consideration, we took petrochemical feedstock industry as one that we can consider a governance structure for. So considering such an industry, we need board of directors for every company. We need leaders that will handle everything. So we look out for the CEOs, COOs, and all head in the industry. Then coming down, we have the management team. So for the management team, they'll be looking out for all the operations and other things. So there'll be junior and senior staff to handle all the management in the facility. And also, we have the advisory body, and the advisory body too is an independent body that gives advice on different suggestions for decision making, let me say it that way. And finally, we also have maybe the compliance team and the compliance and auditing team. So they take care of handling everything in the company, as in their environmental risk assessments and how far they are complying to regulations. Thank you.
All right, thank you very much. So the question on governance structure, I would pose it to Ho Technical University. I think you provided your governance structure, but there was a sub-level that had health workers in there, right, under the health and safety, whatever. What would be their role, their main role in that structure? Are you looking at employing health workers in your company?
Please. Yes, please. Actually, we have the operational unit that consists of different divisions that are we have different divisions like production division, the marketing division, as well as the health, safety, environment, and quality division that looks after the safety and the quality of the industry workers.
So are you looking at employing nurses in your company? That's why I wanted you to elaborate on what category of staff you would refer to as health workers.
Health, safety, environment, and quality workers will be those that
when there is an emergency situations, they will come in. Let's say risk in the production, in the operations, in the company, they will come in and then save as first aid before taking the people to the hospital. Okay,
second question to you. You said you'd use pentane as a refrigerant, right? Yes, but looking at how volatile it is, would you think it would be a better cooling agent compared to, let's say, using propane?
Yes, please. Due to its low boiling point, it will be a better cooling agent as compared to propane.
Okay, so LPG, using it in drying, in agriculture, that was what you said. Yes. How is that possible, or how is that feasible? Is it already being done in Ghana? If no, What's the way out in terms of rolling it out per your projects or per your discussions?
Okay, so the LPG can be used to heat air. That will be used to dry the crops or the haze during in that agricultural processing.
Okay, starting from Ho Technical University, you made a statement here that there are about 12 companies currently importing pentane. You said 4? How many did you say?
We mentioned 12 and we stated 2.
Okay, 12. What do they use the pentane for?
Pentane is used in the pharmaceutical industries, for example, in pesticides, and as well as blending into other petrochemicals.
Do you really have information on this?
Yes, please.
You do?
Yes, please.
So companies such as the KNUST and then other...
Yeah, you mentioned later in your presentation.
Entrance, that's the tobacco. They can also use it.
Are you talking about a 35 ml bottle or 20,000 tons?
Please come again. Please come again with the question.
No, I'm just curious about the amount of pentane which is imported by these companies. If you know. You don't have to know, just want to tell us. Okay. The other thing you mentioned, which is also interesting, is you are suggesting pentane as a cleaning agent or a degreasing agent.
Yes,
so what are we cleaning? What will pentane clean?
Actually, in the electronic industry, for example, the motherboard of computers, it requires cleaning or servicing. And in this servicing, this product, due to its high volatility and the rate at which it evaporates, can be used in cleaning these parts of the computer.
Okay, thank you. Now, KNUST, you also made a suggestion of replacing some material in the foam industry with pentane. So what is the actual advantage of pentane over whatever is being used right now?
Okay, so initially, CFCs and HFCs, which are chlorofluorocarbons and hydrofluorocarbons, were used for the blowing as a blowing agent, and these are potential greenhouse gases. And by using pentane, we're going to cut down emissions and also contribute to SDG 13.
You think pentane doesn't contribute to whatever those ones contribute to? It's also a hydrocarbon.
So actually, ozone molecules help protect the Earth, that's the ozone layer. So with the use of CFCs, we can produce chlorine, where chlorine tends to break the ozone molecules and deplete the ozone layer, causing global warming. So with the use of pentane, pentane will reduce this potential from happening.
I have another question for you, KNUST. The demand for LPG in Ghana right now, are we able to meet it?
No, currently no, because we...
Okay, stop there. Then you are suggesting that we crack it to something.
Yes.
Even as at now, we are not able to meet the demand from the plant.
So that's why it was a long-term option.
Then you are suggesting that we crack it and use it for something else.
So actually, for that option, we suggested that it will be more viable in the long-term run rather than the short-term. So with future discoveries, we will be able to produce more raw gas and process it and gain more production on LPG.
So, well, yeah, that's a good suggestion. But what do you think about rather crack the pentane to what you were suggesting we use the LPG for?
Yes, that is also possible. Just that we didn't consider that.
Okay, the last one to UG. All your presentation was centered on pentane. And one that caught my attention was you suggested some use in the mining industry. What is it used for? Or what is the suggestion?
Pentane is to be utilized as a working fluid in the organic Rankine cycle, ORC. One important part of the ORC is the heating source, which is going to evaporate the working fluid you are using. Now, with the mining sectors, they produce a lot of waste heat from some of their processes like smelting. So that waste heat will be coupled to the evaporator of the ORC system, and that heat will be used to vaporize the working fluid, turn the turbines, produce electricity for that mining company itself.
Oh, no. Okay, go ahead. Okay, we'll come back to that. So there are some other questions for you.
Okay, thank you. So, University of Ghana and Whole Technical University, you provided a price for pentane, and you said we're going to use the netback pricing. Am I right? Eugene?
Yeah. Yes.
Good. Then you had a price of 500, and then you discount that with a certain cost to get to about 3 something. And you said the netback pricing was about 3 something. Is that right? Mm-hmm. Good. Now, because UG and Whole Technical University, you kind of applied it in the same way. I think instead of asking you a question, I rather want to explain. So anytime you are talking about netback pricing, what it means is that we do not have a reference price. So for instance, in your presentations, you said that the price of the commodity is 500, okay? Well, we have to check the price of your presentation. You had 500. Okay, the 500, what was it for?
The market price of pentane.
Of what?
Pentane.
So that's where the challenge lies. If the market price of pentane is 500, then it means that the price of pentane is 500. The principle is when you are moving from the unknown to the known, the netback pricing works. So for example, if you didn't know the price of pentane, the market price was 500, but you knew what the pentane was going to be used for, and therefore that end product has a market price of, let's say, 500. So that 500 should be a price for the final product from the pentane. And then the cost in arriving at that final product is discounted against that final product price in order to get the price of pentane. Okay? So once you say the price of pentane is 500, then it means there's no need to even apply a netback pricing at all. So I think it is consistent with how Who also applied it. So what I'm putting across is that in netback pricing, you use it when you have a challenge with a reference price. So you need to take note of that. Okay. The last question I want to ask you, what are Whole Technical University, again, in your presentation, you said that Ghana Gas intends to have a second plant. You remember that? You said Ghana Gas intends to have a second plant, and it's in partnership with ENI. That's inaccurate, so you need to double check that. Okay? And the reason why I'm taking time to, if you like, correct this, because these are public information, and you don't want a situation where information concerning Ghana Gas is one that does not reflect what is being discussed in public. So that would not be the case, that there will be a partnership with ENI with regards to the second processing plant. Then you also said that demand, the factors of demand, you said urbanization, economic growth. How will that affect demand to Whole Technical University? How does economic growth and urbanization affect demand of commodity? If you could explain that, that would be my only question to you.
Yeah. As for the economic growth, as the economic of the country is being in a well-structured form, most people are now having money and they will not like to maybe use charcoal or the firewood in their heating purposes in the house, or maybe in their cooking purposes. And also, if the economic growth is very well, that means disposable income to each and everyone in the country will be huge, which makes them maybe rich people, and they will not like to use charcoal or wood for their cooking purposes. And for the urbanization, that one, when people move from the rural areas and they go to the cities, they find it difficult to find maybe firewood or charcoal in terms of heating purposes.
KNUST. KNUST. In the course of your analysis, KNUST, in the course of your analysis, the demand and supply balance, was there any point that you established an equilibrium?
No, please.
Okay. Thank you again, and let's give them a hand of applause.
All right, thank you. So you can please calm down. I think all of you would have to calm down because we would have to do some substitutions. So please calm down whilst we look at the substitutions. All right, so University of Ghana does a substitution and brings on another lady. So University of Ghana, we are ready for you.
Go forward. Go forward.
Right. Right. We are ready now. So we are ready. Whole Technical University and University of Ghana, we are ready. Akpena mi kaka 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 kaka. Now we are ready. Akpena mi ho Technical University. University of Ghana, you are done. Now over to you.
Okay, welcome back. We see there's a substitution. So the new lady on stage, please introduce yourself.
My name is Jane Caroline Novice, and I'm a final year chemistry student.
Okay, now it's time for the engineering presentation. Still, it is 15 minutes. If you are ready, you can start, please.
Good afternoon, ladies and gentlemen, panel of judges. My name is Jane Caroline Novice, and I, with my teammates, will be presenting our innovative solution for the construction of an onshore natural gas distribution pipeline. So as you can see in our presentation outline, we'll be tackling some key issues such as our pipeline design, our procurement strategy, our construction and installation techniques, and our procurement strategy. For our introduction, natural gas is a key component in the operations of manufacturing and processing companies. And as Ghana's energy sector grows and increases, so does the demand for the supply of natural gas to these industries. As such, this demonstrates a need to expand Ghana's gas infrastructure in order to meet the growing demand. And so this brings us to our problem statement. Posing as a company, we were awarded an EPC contract and tasked with building a 10-kilometer onshore gas distribution pipeline to supply 10 million standard cubic feet of gas per day to a cocoa processing company located south of an existing RMS. In order to do this, we would have to complete some certain objectives, such as specifying our pipeline parameters. We'd also need to propose a procurement strategy as to how we plan on getting the materials and equipment for the pipeline construction. We would also need to perform a cost estimate and economic analysis. And finally, we would need to propose construction and installation techniques for the actual construction of the pipeline, all the while ensuring compliance with industry standards and national regulations. So looking at the table before you, we're able to utilize these values to calculate the internal diameter of our pipeline, which is one of the most important specifications in designing a pipeline. So for this, we decided to utilize the Weymouth flow equation for a number of reasons. And in the Weymouth flow equation, there are a number of parameters that will have to be defined and calculated for. For example, the specific gravity, the average gas pressure, the average gas flowing temperature, and the compressibility factor, just to name a few. So as you can see from our computations, we were able to calculate all of these parameters, and inputting them into our Weymouth equation, we were able to determine the internal pipeline diameter to be 3.51, or approximated to its nearest value of 4 inches. This table shows a summary of all our calculated parameter values, and for our pipeline specification, we shall be using Schedule 80 pipes with a nominal pipe size of 3.5, or again approximating to 4 inches. It would also have a wall thickness of 8.08 millimeters. For visual context, we included a schematic diagram of our proposed pipeline with the internal diameter, outside diameter, and wall thickness all in millimeters. For our procurement, we will be procuring specifically product specification level 2 pipes. This is because they have higher testing capabilities and values. For the Schedule 80 pipes, we selected this due to their high wall thickness to account for our high velocity, high pressure gas distribution line. We would also be procuring the necessary coating and insulation materials needed for our pipeline and the associated pipe fittings, valves, and flanges. For our procurement strategy, we shall be utilizing an open tendering process to ensure competitive pricing. And for our supply selection criteria, we shall be placing emphasis on technical compliance and price. The Gantt chart over here shows our proposed timeline for our procurement section, with material identification and vendor selection being done at the beginning of the first quarter, and our issuance of purchase orders being done by the end of the first quarter. We expect to start receiving the necessary materials and equipment for the pipeline by the end of the second quarter, simultaneously done with manufacturing and quality assurance checks on the supplied materials. We estimate that by the beginning of the third quarter, we shall have received all the necessary equipment and materials needed for the construction, and we'll begin the next phase, which will be the construction phase, which we estimate will take less than 3 years to bring the project to completion. For our estimated cost, now that we have established our procurement strategy, as you can see from the table, it shows a summary of the various components that led us to get our total estimated cost of about $700,000 to $1.4 million needed to build, design, and construct the entire pipeline and bring the entire project to completion. For our economic analysis, we're able to determine that the pipeline would need an initial investment cost of a minimum of about $550,000 and would have an annual depreciation rate of 10%. However, it would benefit from an annual tax cut of about $9,000 and will have an annual operating and maintenance cost of about $11,000 per year. In order to verify our calculations, we were able to reach out to a pipe company based in China and procured a cost estimate of about $210,000, which is in line with our calculations, showing that we are well within budget. In the procurement of the pipes, materials, and equipment necessary for the construction of the pipeline, there will be some risk involved. For example, there could be expiry of our warranties or expiry of insurances that we have purchased. We can also experience uncertainty in our market supply chain. To mitigate these risks, we have put in place certain measures. For example, we utilized a payment plan to settle all costs. We also consider using a 50% buffer zone in our cost estimation and procurement and construction timeline. We would also consider purchasing lean consider purchasing lien-held items many months before in order to ensure their uniformity in price and to account for market price fluctuations. For the actual construction and installation of our pipeline, we shall be utilizing trenchless installation methods, keeping in mind the complexity and sensitive nature of the proposed pipeline routes. We do this in order to minimize surface and environmental disruptions. So for the forest reserves and for the river crossings and also for moving through densely populated areas, we shall be utilizing the horizontal directional drilling method, also known as HDD. In this method, a small diameter pilot hole will be drilled underneath the river, usually at a depth of 10 to 12 meters. After that, the small diameter hole is enlarged using a reamer head to about 2 times our pipeline diameter. Our pipeline is then pulled through the expanded tunnel, and as you can see in the final diagram at the bottom right corner of the screen, we will successfully be able to install the pipeline with minimal environmental and surface disruption. In regards to the highway crossing, we shall be utilizing an auger boring method. In this method, you have 2 pits which shall be constructed on either side of the highway, which would be the exit pit and the entry pit. So a drilling machine is then placed into the entry pit and used to drill a straight tunnel all the way to the exit pit, after which steel casings are installed in the drill tunnel to act as a protective sleeve and a alignment tool for the insertion of our proposed pipeline. After this, our proposed pipeline is then pulled through the steel casing tunnel, and the excavated pits are then backfilled, and the surface is restored to its original condition. There are many risks and environmental and construction hazards involved in the construction of the pipeline, but at this point, I will hand over to my teammates who will lead us through the rest of the presentation.
Thanks, Jane. We want to analyze some key hazards and risks associated with construction of a pipeline. First of it is trenching and excavation hazards, as workers may be prone to dangers such as trench collapsing and caving in, and unavoidable or human or operator errors. Environmental factors such as ground instability, heavy rainfall, high winds that affect and disrupt construction activities. Increased likelihood of accidents, especially in areas where there is more crowded, more densely populated areas. And there's also a risk of pressures exceeding the maximum allowable operating pressure. Some safety measures put in place to check these risks include usage of personal protective equipment, routine inspection of maintenance of tools used, and continuous monitoring for adverse weather conditions. On the side of the workers, all regulations shall be strictly obeyed, and strict pressure testing protocols will be followed to safeguard the integrity of the pipeline. Some key assumptions we considered during this project was pipeline design calculations, where we assumed the flow to be isothermal, and we also considered steady state analysis. Some environmental and safety assumptions we considered was that we assumed that environmental impact assessment and geotechnical surveys were conducted. Some technical assumptions we made was that we assumed that pigging infrastructure and block road...
You have 5 minutes more, please.
Pigging infrastructure and valves were installed along the pipeline. Some legal and regulatory assumptions was that we assumed that there will be no legal disputes with regards to the route of no legal land disputes with regards to the route of the pipeline. And we also assume that all permits, including right-of-way, have been approved. In conclusion, we have provided detailed calculations on all the parameters needed to calculate the pipeline. In procurement strategy, we use open tendering process. Our project is estimated to cost between $658,000 to $1.4 million. HDD and auger boring drilling methods were recommended to minimize the impact on the environment, meanwhile observing all safety guidelines in our work. Thank you. These are the references we made. Thank you very much.
Okay. Thank you, Legon. You can take your seat now, please.
The next is KNUST, and they have also done a substitution. They have done the substitution.
Okay, welcome KNUST. There's also, I can see, a substitution. So the new gentleman, please introduce yourself.
I'm Ajaman Neko, a final year petrochemical engineering student.
So the engineering problem in 15 minutes, tell us all you've done. So if you are ready, you can start, please.
Okay, so in this presentation, we are going to present on the design of a gas distribution pipeline. Here's the outline for our project. So we talk about the introduction, we move to the hydraulic design for this project. Then also talk about mechanical engineering design, then economic analysis for the different alternate scenarios we considered. The construction and the right of way will also be considered, and finally we conclude on the final solution for this project. So there is the need for us to design an onshore pipeline to transport 10 million standard cubic feet of natural gas from an existing regulated metering station to a cocoa processing company, which is 10 kilometers south of this existing RMS at specified conditions. So here are some of the specific objectives considered in this project. So we perform the hydraulic design calculations of this pipeline to determine the pipe parameters such as the pipe size, flow rate, and also pressure drops along the pipeline. We also perform the mechanical engineering design calculations to assess the structural integrity for the different scenarios we considered. Then we perform the economic analysis of this project and also assess safety and environmental impact of the project, as our pipeline is supposed to traverse through a densely populated area, cross 3 rivers, and also 5 major highways, and also a forest reserve. Here are the general assumptions we assume for our project. So we assumed RMS, that is regulated metering station battery limit conditions, to be 80 bar, 30 degrees Celsius, 70 bar, and 27 degrees Celsius, respectively. We also assume a steady state analysis so that the gas properties remain constant along, doesn't change with time, yeah. So we also assume elevation to be 0, so that we assume the pipeline route to be a flat terrain. And for the length of the pipeline, because the RMS and because the cocoa processing company is 10 kilometers south of it, we assume an additional 10% to account for associated fittings such as valves, flanges, and also bends, so making up 11 kilometers. We assume a pipeline efficiency of 95%, and the flow of gas through the pipeline was assumed to be an isothermal flow. We assume an allowance of 10% to the pipe size to account for future incremental flow. And finally, the pipeline material used was carbon steel API 5L X65. So now we come to the hydraulic design. So for the hydraulic design, it involved a rigorous calculation to determine the pipe size and also the pressure drops along our pipe. In the hydraulic design, we considered 2 alternative scenarios. So for the alternative 1, we consider the upstream gas pressure to be 75 bar, which is exactly the output of the RMS, and it's expected to drop gradually along the pipe length to 10 bar, which is the off-taker specification. For alternative 2, we expect to transport 10 bar exactly to the off-taker, but we assume we don't know the inlet pressure, so we have to use the outlet pressure as our downstream pressure to estimate exactly the pressure coming from the RMS that will drop along the pipeline to 10 bar without the use of pressure regulating valves. So for the first scenario, for it to drop to 10 bar, if possible or if it's not possible, we may introduce pressure regulating valves. Here's a summary of our gas properties calculations, and for the determination of pipe size, we have to get relevant gas properties in order for us to do so. Among them, we have the average molecular weight of the gas and also gas gravity, which is the ratio of average molecular weight to the molecular weight of air. Then for compressibility factor, we calculated for upstream and downstream. This factor is to account for the raw nature of the gas and its deviation from ideal gas condition. Gas densities were calculated for the upstream and also the downstream, and the average gas viscosity was also determined. So this table summarizes all our gas properties that will be used in the hydraulic design.
So in gas pipeline hydraulics, one key parameter pipeline engineers always consider is the erosional velocity of the gas, which is the velocity at which the pipeline will begin to erode. And so, according to industry practice, it is always best when the maximum velocity of the gas in the pipeline is at a maximum of 50% of the erosional velocity to ensure operational safety. And so, based on the gas properties determined, we calculated our upstream and downstream erosional velocity. That's for alternative 1. And for alternative 2, we only estimated the downstream erosional velocity since we didn't know the value of the upstream gas pressure. And so based on that, we sized our gas pipeline for alternative 1 based on upstream erosional velocity. That's, we use 50% of the upstream erosional velocity to determine the diameter. And for alternative 2, we use 50% of the downstream erosional velocity to determine the diameter of the gas pipeline. And after that, we assumed an allowance of 10% for any future incremental flow for both alternatives. And we compared the final pipe diameter to standard pipe sizes on the gas market. And we had a standard pipe size of 9.314 inch for alternative 1, and for alternative 2, we had 6.813 inches. And so each standard pipe size comes with its own pipe specification, including the pipe thickness, the outside diameter, nominal pipe size, and the schedule number. And so for alternative 1, we had a nominal pipe size of 10 and a schedule number of 100. And for alternative 2, we had a nominal pipe size of 8 and a schedule number of 160. After determining the gas diameter, we went ahead to predict the pressure drop along the stretch of the pipeline. That's to know whether there will be a need for a compressor in case the pressure drop is too small to carry the gas pipeline to the downstream end of the pipe, or there will be a need for a pressure regulating valve in case when the pressure is too high to step down the pressure to the 10 bar gauge you will need at the downstream end of the pipeline. And so we used various flow equations, including the Weymouth equation, the panhandle A, panhandle B, and the AGA equation to predict the pressure drop along the stretch of the pipeline. And in doing that, we divided the pipeline into 4 different segments to give a better estimate of the pressure drop along the segment. And also, in doing that, the first 3 segments was 3 kilometers each, and the last segment was 2 kilometers. And this extra 1 kilometer added to the 10 kilometers is to account for the equivalent length of fittings, such as bends, elbows, and also valves. And from the pressure drop predicted by the various flow equation, you realize that the Weymouth equation, which gave the highest pressure drop of 0.19 bar gauge, which is the worst pressure drop, still had a downstream pressure of 74.81 bar gauge, which is not up to the 10 bar gauge we need or we are expecting at the downstream end of the pipe. And so this emphasizes on the need of for a pressure regulating valve to step down the pressure at the downstream end of the pipe. And also after the pressure regulating valve has dropped the pressure, there will also be a significant decrease in the temperature. And so we will need gas fire heaters to also raise the temperature of the gas to the 25 degrees Celsius at the downstream end of the pipe. And for alternative 2, the whole idea is, if possible, to regulate the pressure at the RMS. Then we should regulate the pressure at the RMS to a certain pressure value so that we'll be able to transport the gas to hit at the cocoa processing company at exactly 10 bar gauge. And so we use the various flow equations to back calculate the value of the pressure at the upstream end of the pipe. And based on that, that's assuming if you are using AGA equation to calculate it, then the upstream end of the pipe, you will get a pressure of 13.16 bar gauge, meaning you will need to regulate your RMS to that pressure before you'll be able to transport the gas to the cocoa processing company at exactly 10 bar gauge without the use of any pressure regulating valve. And so after that, we continue to make calculations on the mechanical engineering design. Thus, we estimated parameters such as the maximum allowable operating pressure, the hoop stress, the longitudinal stress, the bursting pressure, and also the hydrostatic pressure, in order to ensure that our pipeline is safe to operate and also to protect the structural integrity of our pipeline. And for any engineering project, there is the need to estimate the economic analysis of the project. That's to ensure or to know whether the project is attractive and viable. And so for our pipeline design, we also went ahead to perform economic analysis on it. And we factored into its parameters such as the CAPEX, which is the initial capital expenditure of the project, which includes the cost of right-of-way, the cost of main line valves, and also cost of ultrasonic flow meters, and the cost of
You
pipeline
have less than 5 minutes to
and
complete.
you also proceeded to make an estimate of the OPEX, which is the operation and maintenance expenditure, which also includes the energy and utility cost, as well as administrative and general expenses. And after that, we went ahead to perform discounted cash flow analysis on our project. And based on that, we were able to determine the net present value and the discounted payback period based on a project's lifetime of 30 years that we assumed. So I'll hand over to my colleague to complete the presentation.
So as said earlier, our pipeline routes, and for our pipeline routes, the pipeline is supposed to traverse a densely populated area, cross 3 rivers, 5 major highways, and also a forest reserve. For that reason, safety of the people and the environment should be ensured. So for our pipeline, for this stage, our pipeline will be buried to a depth of 1.5 meters minimum for highway, 1 meter minimum for forest, and also the 2.5 minimum for river crossings. So for the river crossing and the highway crossings, we use the horizontal directional drilling for technique to bury the pipeline in order for us to protect the aquatic life and also prevent damage to the pipeline due to high traffic on the highway. So all safety signs and protocols will also be observed to ensure maximum safety of people and protection of equipment. So here's the model of our pipeline. So after simulating our pipeline using Aspen HYSYS, we got our cocoa processing plants and our also RMS. So along the stretch of the pipeline, taking the others into consideration. In conclusion, after going through the hydraulic design calculations, and also ascertaining our mechanical engineering designs calculation, we came out with an economically viable option, which is NSP 8 and the alternative 2 design, which proved profitable and gave the highest NPV. So environmental and safety considerations were also duly assessed. So here are our references. Thank you.
It's not bad that they missed some few things.
Thank you, KNUST. We would have the whole technical university take on their part.
Okay.
Team Alkane, there's a substitution. So the new man on stage, can you introduce yourself?
My name is Kwao Kolola, level 200 student, BTech Design Manufacturing Engineering.
Okay, all right. So in 15 minutes, tell us about your engineering solution.
Okay, so we are here to present on the topic gas pipeline construction. Our presentation outline includes project overview, engineering procurement contract, feasibility analysis, engineering consideration, pipeline design, pipeline routing strategy, all through to cost estimation and cost analysis. Our company, Akin Ghana Limited, has won a contract to do an engineering procurement and construction of a 10 kilometers pipeline to transport natural gas from a metering station to a cocoa processing plant. The pipeline is set to pass through these places: a forest reserve, a densely populated area, and to go across 5 major highways and 3 rivers. Our aim is to provide a reliable, cost-effective, and environmental-friendly gas supply to the cocoa processing plants for their operations. And an engineering procurement contract is a contract that gives the responsibility to the contractor to engineer, procure, and construct the project to the commissioning of the project. The engineering aspect of this talks about the pipeline design and also the maintenance of the pipeline system for transporting the fluid to its destination. The procurement talks about the process of acquiring the pipeline equipment and also materials to the site for the pipeline to be constructed. The contract is just the formal agreement between the contractor and then the company. And this involves the timeline the pipeline will be executed and then the responsibilities as well as the payment terms. A well-structured pipeline contract is essential because it manages for risk and ensures project success. For us to construct our pipeline, we conducted a feasibility analysis to see whether our project will be viable when it is being executed. In this, we consider the technical feasibility, which talks about the technologies to be used in the construction of this project. Technologies such as the AGA and then the machine used for the HDD. We also did feasibility about the economic viability, which talks about the costs to be incurred during this project and as well as the funding sources and then the rate of return on the investment. Legal feasibility, that talks about the regulatory compliances, both local and national, and as well as the permitting and approval of lands also. This is the composition of the gas to be conveyed by our pipeline. From the composition, we have seen that the gas to be conveyed is a lean gas, and therefore, in the composition, it has helped us to determine the mass of the gas, leading to the determination of the gas gravity, which helps us to find some parameters that are showing on the screen over here to determine the diameter of the pipeline. These parameters were determined by us through various equations and formulas used. In determining the pipeline, we use the AGA equations, which we've determined to be the suitable equation to find our pipeline diameter. In determining the diameter, we've gotten the diameter to be 7.185 inches, of which we will consider an 8-inch diameter for allowance purposes and future incrementation. Pipeline design talks about the creating of specification and layout in the pipeline that's focused on the flow, the pressure, the temperature, and as well as the diameter of the pipeline. In the designing, we consider the joining method to be used to join the segments of the pipe, and we consider almost all the joining methods, such as the shielded metal arc welding and others, and we prefer the gas metal arc welding to all of them due to its speed and then efficiency, quality of weld, versatility, and less cleanup after work is being done. And it can also be automated if we like. Also, we consider the safety of the pipeline, as it is the priority of an engineer to consider the safety of himself and others also in the society. So in the coating, we talk about different types of coating depending on the media through which the pipeline will pass through. So taking as example, in the soil or on the surface of the land, we will be using a tape wrapping coating, which is what we will be using. And then for the river crossing, we will be using the epoxy method, and as well as the cathodic protection to protect our pipeline. The cathodic protection involves the use of electricity. And then in this process, we assume the pipeline to be the cathode, and then an anode is being produced. Those who did chemistry will understand this better. To talk of the routing of the pipeline, I will give it to my brother to continue.
Okay. With the forest reserves, we consider so many routing methods, but we came about with the trenchless method, which involves a minimal clearing, a selective clearing employed with a minimal right of way to avoid environmental impact. And the site assessments were conducted to identify the risks and establish buffer zones around the pipeline to prevent growth of trees around the pipeline. Then when we come to the routing through the densely populated areas, we consider so many routing methods, such as the trenching along the nearby roads and railways, the boring method, and the horizontal directional drilling method. But we'll be employing the trenching along nearby roads and railways because it provides easy access to maintenance purposes and streamline permitting costs. Routing pipelines along nearby roads simply lowers environmental impact, as said earlier. Then when we consider routing through river bodies, we consider the open cut crossing method and the horizontal directional drilling method. The open cut crossing method will be employed where we have shallow rivers, and where we have shallow rivers where part of the river will be blocked and a trench will be dug through and the pipe will be laid through. And when we come to deep rivers, we'll employ the horizontal directional drilling method, which minimizes surface distraction, flexibility, and is having properties as in flexible, and it is steerable and suitable for varied terrains. When we come to road, we will use a trenchless method for installing pipelines. That is the agar boring method, which involves drilling horizontally to create a borehole for the pipeline. It purposely allows precise placement of the pipeline suitable for various soil types and low operating costs as compared to the HDD. After routing our pipelines, we'll consider a hydrostatic pressure testing. This procedure will be used to check the integrity and then the strength of the pipeline by filling the pipeline with water at a very high pressure to exceed its maximum allowable operating pressure for at least 4 to 8 hours. And it will be done to check for the leaks, the flaws, and the structural weaknesses. After we've considered the hydrostatic pressure testing and we've found out that the pipeline is fit for purpose, we'll employ the bag filling, which includes the recovery of the place that we've trenched back to its original state, and it protects the pipeline, ensures stability, and restores the environment. Some of the environmental impacts and mitigations incurred during the pipeline routing were the land disturbance. The land disturbance, it comes as in the habitat loss, mostly when we come to the clearing of the forest. So to mitigate it, we minimize the clearing. And then the water contamination. Water contamination, mostly it comes with the open cut cross-cutting method. But we'll be using the HDD through river bodies to prevent the destruction of the river beds. Then the soil erosion. With the soil erosion, we'll be using silt fences to prevent the washing away of the soil. Then the air pollution. The air pollution, mostly it comes with the agar boring method. Mostly during the dry season and you are using the agar boring method, you could notice that there will be so much dust. So we'll be using the water spray method to minimize the dust in that area. Then the wildlife disruption. As we've said in the land disturbance, we will ensure the planting of buffer zones around the pipelines so that even if we clear the forest grass, still the animals will still be there. With the safety and the risk management, we'll ensure the installation of pressure regulating devices such as the pressure.
You have less than 5 minutes, please.
Pressure regulating valves, then the leak detection system, emergency shutdown system, gas sampling system, pipeline makers, proactive monitoring and maintenance system, all to ensure that the pipeline will be safe. After considering the feasibility analysis, we came to the cost estimation, which includes the cost, the material cost, the labor and the equipment, the mobilizer and the demobilizer, through to the engineering and the design costs that will be incurred. We analyzed the cost estimation by the cost analysis, and we had a pipeline of carbon steel API 5L by 65 with the detail of about 600 tons and transportation fee included, we'll be having a price of about $2,200,000 US. The cathodic protection for river crossing, $374,000 US, through to the miscellaneous cost costing about $7 million US, which includes the road permitting, environment assessment design, through to the maximum total cost, which will cost about $33,831,850 US. With a pipeline of diameter to be 8, ensuring technologies on it such as the cathode protection, the gas metal arc welding, and using safety devices such as the pressure regulating valve, we came across that our company, with all these technologies involved, will be able to provide the cocoa processing facility with an efficient, cost-effective, and environmentally friendly gas for its process. Thank you.
Right. So thank you very much. And so we would have the rest of the schools on stage whilst we prepare for questions.
Okay, welcome back. Welcome back.
Thank you.
They need to listen. They need to listen to the questions. So please, we'll have time for all the noise making. We also enjoy it. You know that. So the three institutions are back on stage, and here they are going to educate us on things we didn't understand. So the questioning starts from Lady Portia.
All right, thank you so much, Doc, and well done to all the teams. I think you put up a brilliant presentation, and so we want to know if indeed you understood the concepts, the engineering concept and all the scientific stuff you were saying. Okay, so Yuji, my first question, I think you said you wanted to procure some items. I believe you wanted to say long lead items, right? Okay, all right. So what are long lead items? Or what is a long lead item?
They are items that must be procured well in advance in order to avoid changes in their original selling or market price.
All right. So, okay, all right, it's fine. And then you assumed that your permits and legal requirements, you've already obtained them, sort of, right? What permits are you looking at, and what regulatory authorities are you seeking to get these approvals from?
For the permits, we were looking at the road crossing permits and the river crossing permits. We would also look at permits that allow us to go through densely populated areas as they belong to the residents of the area. As to the regulatory bodies in charge of that, I suppose we could consider the Forestry Commission in regards to the forest reserve and moving through the densely populated area, I guess we would have to consider the perhaps discussing compensatory packages with the chiefs or owners of the lands themselves.
No EPA permits?
EPA permits, right? Environmental protection.
All right, that's good. So why do you assume isothermal for your gas flow equations?
In steady state analysis, it is one of the accompanying assumptions that would come with that.
Sorry?
In steady state analysis, that would be an additional assumption that would come with that.
Okay, and what's the unit length of the pipe in your cost estimation?
The unit length is 10 kilometers.
All right, thank you. So, my colleague.
Just a quick follow-up on that. So, you intend to pay compensation to landowners?
If need be, yes.
But in terms of the regulatory body?
If they have permits that we are required to buy, we would pay for them.
Did you have that in the course of your assessment? Did you?
Yes, we accounted for that.
And which regulatory permits will be required?
Road crossing permits and river crossing permits.
With regards to the density or the densely populated area?
For them, we would either have to consult with the chiefs who own the land or the residents themselves, assuming we're passing through private property.
Well, if the District Assembly refused to grant you permit, what would be your alternative to that?
One thing we could do would be to maybe offer higher compensatory packages, or perhaps we can make a case as to how us constructing a pipeline through their town is actually going to benefit them in the end. Assuming the cocoa processing plant is near the densely populated area, it would help with their, I guess, overall economic growth.
Great. May I suggest that we keep quiet whilst they answer, because you may think that we are encouraging them to say the right thing, but you actually distract them. So may we observe Saren for that? Great. KNUST. I noticed you had a rate of return of about 48%. Can you walk us through that? What's the basis of that?
Yeah, so for the rate of return for the first alternative, it was 46.4%, and for the second one, it was 46.6%. Yeah, and so we did that based on discounted cash flow analysis. That's factoring into consideration the time value of money. That's to say that, let's say if you have $10,000 today, within the next 10 years, it will lose its value. It wouldn't be $10,000. And so based on our analysis, as if we had an initial capital investment of, let's say, 100 million, that's the initial capital. So already we are owing. So you'll have to work, that's the gas flowing through the pipeline will have to later in the next 30 years of our project gain interest or, let's say, break even. Revenue. And that's get a revenue. And so if we are already owing that's $100 and our annual cash flows are, let's say, 10 million, let's say $30 million every year, then based on that $30 million, since we have factored into it the time value of money, the next year it wouldn't be $30 million. That's the money will lose its value. So let's say the actual money in the future for the next year will be around $29 million. And the next will also be 28 through to the last year. And based on that, we did some iterations to get that's the actual depreciation rate. And that value was a 46.4%.
I must say I'm a bit confused now. Yeah, okay. But just to help, given the nature of the contract, that you've been contracted as an EPC, what will be the relevance of internal rate of return and the cash flow in terms of revenue that you mentioned?
Okay, so since we are designers, and we want to present this to our the person who contracted us. We need to get exactly the economically viable option for them. So we have to calculate all these for them to know the most economically viable or attractive option to choose from.
Yeah, and so based on the annual cash flows and the revenue generated, that's for the two different alternatives.
Okay.
You could realize that for alternative 2, the revenue was much higher than that of alternative 1. That's to say that alternative 2 was more attractive compared to alternative 1. At the end of the 30-year period, we assumed that our pipeline will last.
What were the elements of your revenue in arriving at your internal rate of return? What was the element of your revenue, given the requirement of you as an EPC?
So actually, to calculate the revenue, we factored into it the capex of the whole project and the OPEX, that's operating expenses and the initial capital investment, and the series of cash flows that comes as annually. So we summed the series of cash flow that's based on the time value of money, and we subtracted the capex and the OPEX from it to get the annual net annual revenue for net present value for the timeline of the project.
I wanted a bit more clarity, because what I'm asking is that, when you are an EPC contractor, and I was impressed with your answer that what you wanted to show to your project benefactor is that maybe the options and how cash flow will do. So I wanted to understand, in terms of the revenue, what are the components of revenue? Do away with the CAPEX and the cost, but in terms of the revenue.
So in calculating the annual revenue, we take into consideration factors such as corporate tax, your operating expenses, what we took into consideration, what are the components of the AR. So the corporate tax, the variable operation and maintenance cost, also the return on regulatory asset base, and also depreciation on our regulatory asset base. That's, it was based on the amount of money the cocoa processing company will pay to you, even the 10 MMSCF of gas. So
okay, we can come back to it. My last question to you will be the right of way. Did you factor that as part of your cost build-up?
Yes, please.
Okay, and so what that means is that the 2 million project cost includes the right of way?
Yeah, everything.
Okay, how much was the right of way for how many kilometers?
So the 11 kilometers, right? Yeah. So our kilometers was 11 kilometers actually, not the 10, because we actually assumed, let's say, a 10%, an extra length of 10% to account for, let's say, valves and other fittings that will be part of our pipeline system, such as elbows and bends. And so in estimating our right of way, we actually based it on a percentage of the capex. We expressed it as a percentage of our capex in our actual report that we submitted.
Thank you.
Okay. Still on lean gas. That was a good approach to, the hydraulics, to use two alternatives and then try to choose one. Now, the issue here now is that there's this probability of a liquid dropout in the pipe if you take the two options. Do you agree to that?
Please, can you make it clearer?
There's what is called liquid dropout in the pipe. Depending on how you approach the design, and in the two cases, it looks like it's possible that there could be a liquid dropout. And if you agree, how would you avoid that?
Yeah, and so to avoid, as for alternative one, I agree in both alternative that there could be a liquid dropout at the end of the pipe, and so to actually avoid that, we could employ the use of, let's say, a strainer to actually collect the gas, the oil droplets, the liquid droplets from the gas pipeline system. Should there be any liquid droplets? And also we could use pipeline pigging, like we can attach pipeline pigging and perform other pigging activities on the pipeline, maybe regularly, to actually devoid the pipeline of any liquid droplets in it, using smart pigs or intelligent pigs.
You are going into a different area altogether. Say during operation, you can't use the pig. You have to shut down before you use the pig, isn't it?
So mostly now actually pipeline pigging is used whilst the pipeline is in operation. So it actually utilizes the flow and pressure of the gas to also move. So the pipeline pigs use the flow and pressure of the gas to move. So it utilizes, like it's actually used when the pipeline is in operation, not when it's in shutdown rather.
The next one goes to Tim Alkane. We'll come back to you very soon. Tim Alkane, a very good presentation on the idea of using cathodic protection, you called it. So I'm going to ask a simple one. Can you mention two materials that can be used as the anode in trying to protect that API 5L X65 pipe?
Yes, please.
Okay, go ahead.
Please, iron and zinc.
Iron and zinc, yeah, that should be fine somehow. Hold on, let me do just the last one to these guys, then I'll come back. Okay, propane. You ended up choosing the Weymouth equation for your calculation. You had the chance to use more than 4. You have a whole lot of equations. So what's the typical advantage of the Weymouth equation over the others?
Well, the Weymouth equation is suitable for pipe diameters of less than 12 inches. It's also suitable for short lengths, that is pipelines less than 20 miles. It is also applicable for steady state analysis and for turbulent flow.
Okay, some of those you've said may be true. You ended up with a diameter of the pipe, it's close to 3.5 inches.
Yes, please.
Do you recall the flow velocity in such a pipe for this project?
Yes.
What was it?
We had 9.73 meters per second.
For a 3.5 inch pipe at those pressures?
Yes, please.
It's going to be way, way, way more than that. And the second question before it goes to the next person, in the pipeline industry, the size 3.5, is it available?
Yes.
So the sheet you showed from, you said a Chinese company.
Yes.
What was the diameter quoted?
4.
4?
Yes.
Yeah, it tells you something.
Yes, we approximated to 4.
Yes, 3.5 may not necessarily be available in the industry. That's what it means.
Okay.
So back to KNUST. Looking at the scenarios that you've proposed, are we looking at a variation in the pipe thickness, right? Considering the various route scenarios that were given in the question, the original question or the problem statement. Are you looking at a variation in pipe thickness?
That was for alternative 1. So I think for alternative 1 we had a pipe thickness of 0.71, and that thickness isn't going to change. So it will be the same throughout the length of the pipeline. And for alternative T2, also the thickness will also not change. It will be the same throughout the stretch of the pipeline.
Okay, all right, thank you. So back to you. What design factors are you looking at, right, in the construction of the pipeline in the densely populated area?
Okay, so our design factor was 0.4.
Class 4 location.
And was a class 4 location design factor. And this was because of the fact that even in the densely populated area, there will be more than 4-story buildings, meaning the place is crowded, so there will be more story buildings at that location. And more than 4-story building calls for a class location of 4 and a design factor of 0.4.
Just for my education, is my understanding right that in your two scenarios, your pipe thickness will be the same regardless of where or the terrain you are in?
Yes, please.
So does that mean if you are crossing river, road and all that, the thickness will not change from a terrain where the likelihood of stress on the asset or the pipeline is less? Is that the case?
Yeah.
All right. Investor of Ghana. So, in terms, how do you intend to ensure community buy-in? I asked that earlier, but I'm repeating that, then I'll link it to another question. How do you ensure community buy-in?
We would offer higher compensatory packages for one.
Okay. So in scenario where the community resists a pipeline, what would be your alternative?
I guess we would simply have to reconsider other pipe routes.
Okay. Now, you also estimated that construction will be less than 3 years. Is that right?
Yes, please.
Have you averted your mind to the contractual obligations?
Yes.
So given that your estimated period, even though you say less than 3 years, what would be your ideal period in terms of the length of construction or the timeline for construction?
Ideally, we should complete it in 2 years. However, we will employ, like I said, a 15% buffer zone in our project procurement and construction timeline.
So if your contractor or your project benefactor has given you 15 months and you intend to do 24 months, who caters? What will be the cost implication and who caters for that cost?
We would have to bear the cost of that.
So, and how would that impact on your margins in terms of the total cost of your investment?
It would cause our upper limit of 1.4 million to go up, seeing as we have incurred extra costs because of delays in our construction and procurement.
Okay.
All right, thank you so much. Ho Technical University, in your submission, you said that you do cathodic protection, right? Yes. Can you educate us on what it is and your justification for choosing that method, and also the types of cathodic protection that we have? Thank you.
Okay. So cathodic protection is just an efficient method of protecting the pipeline, which intend to consider the pipeline as the cathode, and then an anode is being provided. It has two different types: the sacrificial anode method and then the impressed cathodic protection method. In our work, we use the impressed cathodic method because it is more efficient as compared to the sacrificial cathodic protection method. The impressed cathodic protection methods involve a supply of electricity from an external source into the protection system, which allows it to live or protect the pipeline for a longer period, and also is consistent in terms of protection. And that of the sacrificial one, that one is a direct connection from the pipeline to the anode, and therefore the anode takes the rusting of the pipeline. The electrons move through the soil, and the soil is considered as the electrolyte. That's the material that can conduct electricity, and the soil can do that. So they exchange electrons, and that in doing so, the elements that will cause rusting on the pipeline usually moves to that of the anode, and the anode becomes the sacrificial rusting metal.
My last question to you. You said you would.
Is it on? Yeah.
You said you would coat and wrap your pipelines. What do you seek to achieve by doing that? Is it like a safety or a pipeline protective mechanism?
Yes, it's a protective mechanism to prevent rusting. So we chose different types due to where the pipeline will be passing through. So if it is maybe in the soil or on the surface, maybe through the forest reserve, we will use the tape wrapping method. But in rivers, we will be using the epoxy coating, which is more stronger than the tape wrapping.
All right, my very final question. Did you consider hydrate formation as a possible occurrence? Right.
Hydrate formation?
Yeah.
Where? Please, where?
Okay. With the drastic drop in pressure, are you anticipating to have hydrate form?
Hydrate form, okay. So that one, the temperature actually will be kept constant using heat exchangers, and doing so, it will remove the moisture from the pipeline that cannot cause hydrate formation. And also, if there is a corrosion inhibitor through the pipeline, that will surely prevent the internal surface of the pipeline from corrosion.
All right, thank you.
Ho Technical University. So in your presentation, you stated that you intended to open cut shallow rivers. Assuming you are the construction is taking place in a rainy season, what will be your option?
Please, that's why we are using the two methods as a go. So in the rainy season, that means the open cut method will not be suitable. So we use the horizontal directional.
maybe you've answered this earlier or in your presentation. I didn't hear that. So if you can walk me through how you intend to drop pressure from the high pressure, the RMS, to the off-taker point.
Okay, so actually the valves that will be placed on the pipeline will drop the pressure to a certain level. And if it doesn't meet the 10 bar gauge, we will use pressure reducing valves to reduce the pressure to that.
And at what point, in terms of your pipeline right of way, would that happen?
That will be at the outlet of the pipe before the processing facilities meter.
So you also said that you're going to use trenchless method. Trenchless method. So do you intend to use HDD throughout your construction?
No. That's why we gave specifications. We gave different specifications pertaining to the mediums that the pipeline will be passing through. So it's only in river that the HDD will be applied. And then through the densely populated area, we will look for maybe a possible nearby road and direct the pipeline through that place. But in cases where it will not be possible, we may use the directional drilling method. And that one, I think it will delay because permitting and other things will cause the delay. So we will go for the using of the nearby road and then passing the pipeline through, as they've been doing for water pipelines.
How do you intend to convince the regulators to grant you all your permits?
Okay. As for the forest reserve, the permitting, it will be a little bit difficult because we want to pass the pipeline on the surface. It will delay a little bit because they will be like maybe it will affect people over there. But here lies the case in the forest reserve. It is like people doesn't even go there like that because it is reserved for a purpose. It is reserved there for a purpose. So people doesn't go there maybe to go and fell trees or do something like that. So it will not actually do anything, and the permitting will be granted.
Last question to University of Ghana. How do you intend to drop pressure from the SRMS to the delivery point?
We will install pressure relief valves along the pipeline.
So how do you intend to do that?
Well, we've not done any specific calculations as to where exactly along the pipeline we will install it, but we assume that we will place pressure relief valves towards the outlet of the pipeline.
Okay, thank you.
Okay, one more question from me. This one goes across for all institutions. So starting from University of Ghana, you had a design pressure and there is a maximum allowable operating pressure. So how now, for safety reasons, you don't want to go above the maximum operating allowable pressure? How are you going to ensure that?
Well, the maximum allowable operating pressure for our pipeline, we calculated that to be 2,800 to 3,200 psia, and our operating pressure is about 700 psia.
So we use pressure relief valves. Pressure relief valves or HIPs.
Pardon?
Pressure relief valves or HIPPs.
On the pressure relief valves on the pipe,
Yeah.
right? KNUST, how would you achieve that? That the pressure doesn't go above the maximum that you want it to go?
And so, from the Ballows formula, the wall thickness of the pipe is dependent on the outer diameter as well as the maximum allowable operating pressure. Okay, so that is to say that the maximum allowable operating pressure is inversely related to the diameter of the pipeline. And so if we can increase our internal diameter, which will in turn increase our external diameter, then it means that we can cause the pressure in the gas pipeline to, the maximum allowable operating pressure in the gas pipeline to fall. That's possibly, as the gas flows from the RMS, from 75 bar gauge through to the downstream end, the pressure will be falling at a faster rate compared.
Let me put it differently. So what is, in your case, what will be the maximum allowable operating pressure?
So it will be the 75 bar gauge.
I don't think so. Whole technical university.
The maximum allowable operating pressure of the pipeline, we estimated it from the Ballard's formula, and I actually don't remember the actual value we had.
Yeah, I mean that one.
Yeah, but it was in our presentation.
Yeah, that's fine.
We use that to estimate it.
So the question is, how do you prevent the pressure from going above the maximum operating value within the pipe?
Okay, so we can do that by for the pressure coming from the RMS, we can regulate the pressure at the RMS, or that step it down to a pressure below the maximum allowable operating pressure, as we did in the second case, which we had a pressure based on the AG equation to be about 13, so that it will flow through the pipeline, and as it flows, the pressure will also be decreasing, and so there is no way it will increase again to that 75 value. To that maximum allowable operating pressure.
Okay, thank you. Whole technical university, do you have any idea?
Okay, for the pressure to not exceed the operating or the maximum allowable pressure, we use pressure relief valves and HIPPS system. HIPPS on the pipeline.
Pressure relief valves on the pipeline. Okay, thank you.
Right, so right, so thank you very much. This has been a difficult and an engaging one. We are grateful to all the institutions, starting from yesterday in the morning where we had the Zone 1 contest in the morning. In the afternoon, we had the same Zone 2 contest. This morning, we had the Day 2 Zone 1 contest. And this afternoon, we have had Day 2 Zone 2 contest. Ladies and gentlemen, this brings us to the end of the prelims of the innovation edition of the Gas Challenge, which happens to be the 5th anniversary edition of the Gas Challenge. We are grateful to each and every one of you for making time and joining us by every means, by ear, voice, and text. And we want to say a very big thank you to all of you. We are looking forward to the fact that the judges will release the results, and that will determine which 6 institutions will make it to the semi-final that will come off at the Kwame Nkrumah University of Science and Technology right in Kumasi on the 5th of November. And then the final comes off on the 14th of November. Well, will it be Takoradi Technical University? Will it be KNUST? Will it be University of Ghana? Will it be All Nations University? Will it be Whole Technical University? Will it be All Nations University? Will it be Regional Maritime University? Will it be Regional Maritime University? It looks like everybody thinks it will be them. But however, ladies and gentlemen, whoever it will be, the judges will decide and the results be announced. Until we meet again right at the KNUST College of Engineering Auditorium, it is bye-bye from the Gas Challenge. Whether I can go ahead. Right, thank you very much for this exciting contest. It's been very interesting, it's been very heartwarming, it's been lovely. At the end of the day, some hearts will certainly be broken. And so at this juncture, we have had 12 institutions contesting in the innovation phase of the gas challenge. And like we have announced rightly so, 6 institutions will make it to the semi-finals. And these institutions will be based on the scores that they obtain. And so we are going to accumulate the scores from the reports they have presented, and then from the presentations they made, and then from the question and answer sessions. And so an accumulation of these results gives us the 6 finalists that will be going into the semi-finals. At this juncture, ladies and gentlemen, I have the singular honor to announce to you what the results are and what did the judges say. Who did what at what point in time and how did you look like? So right behind me, as you can see on the screens, we have the results, and we have 81.52, 76.03, 70.90, 69.27, 63.53, 60.88, 60.87, 59.57, 58.07, 57.43, 50.50, and 46.77. So at this point in time, the first institution to make it to the semi-finals of the Gas Challenge 2024 is Takoradi Technical University with 81.52 points. The second institution to make it to the semi-finals is University of Mines and Technology with 76.03. The third institution to make it to the semi-finals is the Regional Maritime University
who obtained a score of 70.90. The fourth institution to make it to the semi-finals is Kwame Nkrumah University of Science and Technology with 69.27. The fifth institution that made it to the semi-finals is Kumasi Technical University with 63.53. And the seat or the final institution that made it to the semi-finals is the University of Cape Coast, who obtained 60.88. And so, ladies and gentlemen, these are the 6 finalists to the semi-finals. We have Takoradi Technical University, University of Mines and Technology, Regional Maritime University, Kwame Nkrumah University of Science and Technology, Kumasi Technical University, and the University of Cape Coast. To the other institutions who couldn't make it, we wish you a better luck next time. And to those who move to the semi-finals, see you in Kumasi. And this is what will bring the contest to an end. I say Aligasta. Thank you.
Good.